Welcome to our lesson on one-step equations and one-step equations with fractional coefficients. Now, the beginning part of this lesson looks like a review, but there is something different about these types of problems. So let's go ahead and take a look for a moment. What do all of these have in common? All of these problems here have in common that is different than what we have seen before. I want you to think about that for a moment. Okay, hopefully you notice that the variable is coming second in all of these problems. It says 12 plus m, negative 9 minus x, negative 7 plus y, and so on. So at the very top of your paper, before we start, I want you to write something out. And I'm going to type it because it's hard for me to write using this, but you're gonna write it out at the top of your paper. So here's the note. I want you to write, if the variable, oops, sorry about that, if the variable comes second, use commutative, and let me pull this down a little bit, sorry about that. Okay, use commutative property to move, I'll just say x, could be a or m or whatever, so it is first. Okay, if the variable comes second, like in this problem right here, how it says 12 plus m, or this problem right here, negative 9 minus x, we're going to use the commutative property to move x so that it's first. Now, the thing about commutative property that you have to remember is we can only use commutative property with addition and multiplication, but that doesn't apply here. We can't use it with subtraction, so we'll talk about what to do in that situation a little bit later. So, there is a way to solve these problems without moving x so that it's first, but there's usually a lot of errors that are caused when people forget to move the variable first. So just to be on the safe side, I'm going to ask that we move the variable so that it comes first. In other words, rewrite the problem. This is already a plus sign. Remember, commutative property means you could move something around. So like 2 plus 3 is the same as 3 plus 2. That's commutative property. You can kind of like flip-flop them around. So I'm going to use commutative property here. M plus 12 equals negative 30. Okay, now this is just a normal problem. I can ask myself the set of questions that I have been asking myself. What is happening to m? Well, we're adding 12. How would I reverse plus 12? I would subtract 12. So it's the same steps as before now. You're going to subtract 12 from both sides, and you get m equals. Now, there's a lot of errors that can be made over there with that problem, so I'm going to just kind of write it out over here. And remember that it's sort of like a leave change opposite problem, where negative 30 plus negative 12 is actually negative 42. Okay, so there's my answer. Now, of course, I want to be able to check my work. So off to the side, I'm going to plug in negative, oh, I didn't mean to do that. Sorry about that. I'm going to plug in negative 42 instead of m. And I can use the original problem, and I would recommend that. So 12 plus negative 42 should equal negative 30. Okay, and then 12 plus negative 42 is, in fact, negative 30. So negative 30 equals negative 30, and I put my little check mark to show, yes, it worked. Now, earlier I said I would recommend using the original equation. Definitely do that. Plug it into the original equation, because if you accidentally switched the numbers around incorrectly, you still won't know whether your answer is right or not. Okay, so the next problem. This is a trickier problem, negative 9 minus x equals 2. And the reason it's tricky is because you can't swap things around with subtraction. So let me give you an example, and you don't need to write this out, but you could just watch. If I say 20 minus 5, we know that that's 15. But if I say 5 minus 20, that's a totally different problem. That would be negative 15. So you can't just switch things around with subtraction. But what you can do, so 20 minus 5, let's say I wanted to switch them around, I would do a leave change opposite, and I would make it 20 plus negative 5. Negative 5 plus 20, now it's flipped around, but they're the same thing. So that's what we have to do here, is we have to do leave change opposite first, so negative 9 plus negative x you can put it in parentheses if you'd like, equals 20. And now I'm going to switch them because it's an addition problem now, so I can just kind of flip-flop them around. Negative x plus negative 9 equals 2. Now, we can kind of go through our step-by-step process. What is happening to x? We are adding negative 9. So to reverse add, I would subtract, and my evil number is negative 9. Now, we know, though, that minus a negative, so let's look at this over here. Negative 9 minus negative 9. It's obviously going to be 0 because I want to cancel it out, but really minus a negative is the same as plus. So if you want, you can actually change that. So instead of minus negative 9, because that looks really complicated, you could just say plus 9 on this side, and then plus 9 on this side. Now, I'm left with negative x equals 11. Now, if you had left it as minus a negative, 2 minus negative 9 is still 11. So you still have the right answer. Okay, now I'm not done because negative x is not just x alone. So I have to divide both sides by negative 1 to get x completely alone, and I get x equals negative 11. Now I do want to check that, and like I said before, I want to check it in the original equation. So negative 9 minus, and then instead of x, I'm going to say negative 11, and it should equal 2. So let's check that out. Negative 9 plus 11, because leaf change opposite, equals 2, and it's true, 2 equals 2. So I was able to check my work. And I apologize for it being a little bit crowded on the screen right now. It's always a little bit hard for me to write using the screen. Okay, so I'm going to make myself a little bit more space right here. Number 3. We have a plus sign, so I can just automatically flip it around. So it's going to say y plus negative 7 equals negative 15. And again, I could say minus negative 7. That will cancel out. Or minus a negative is the same as plus, so I can just say plus 7. Now, the ultimate goal here is to get y alone. And so sometimes people are confused, like, should I do minus a negative or should I do plus? As long as it cancels out, it's fine. So negative 7 plus 7 is canceled out. So it's y equals negative 8. And again, I would want to plug that in. Negative 7 plus negative 8 should equal negative 15. And it does. Okay. And then my last problem here for this type of problem, I am going to need to do a leaf change opposite because right now it's a subtraction. So negative 10 plus negative a equals negative 4. Now I can flip them around. Negative a plus negative 10 equals negative 4. Again, I've got plus and negative here, so I can either do minus negative 10 or I can say just plus 10 on both sides, which is the simpler version of saying minus and negative. I'm left with negative a equals 6, and then I'll divide both sides by negative 1, and I get a equals negative 6. And of course I would want to plug that in, so I'm kind of running out of space, but I'll do it up here. Negative 10 minus negative 6 equals negative 4, and then I do leaf change opposite, and I get negative 4 equals negative 4, and check that works. Okay, on to the next slide. What is happening to x in all of the examples below? Well, you can see, and you can see actually more of them on your paper than I can see on my screen, but they are all being multiplied by a fraction. So how do we get rid of multiplication? This is fraction, by the way. We would normally divide, but here's the thing. We don't ever divide fractions. So the next question says, what do we do instead of dividing fractions? What we always do is we multiply by the reciprocal. So make sure you're writing that in. Multiply by the reciprocal. Okay? All right, so from here, we can kind of figure this out. So normally you would say, okay, it's being multiplied by 2/3, I'll divide it by 2/3. But like I just said, we don't ever divide fractions. So we're going to show that we're multiplying, so you're going to put the multiplication dot on both sides. And we're going to multiply by the reciprocal, so by 3/2, and then same thing over here, by 3/2. Now, 3 over 2 times 2 over 3, those all cross-reduce to 1s. So we're left with x equals, and then if you can cross-reduce, that makes it simpler. So 10 and 2 are both divisible by 2. That would become a 1 and a 5. 5 times 3 is 15. And of course, we are definitely going to want to check our work here. So 2/3 times 15, or 15 over 1, should be 10. And let's check it. These are both divisible by 3. That becomes a 1 and a 5, and then 2 times 5 is 10, so it does work. Okay, next problem. I'm, again, going to multiply by the reciprocal because I don't divide fractions, so I'm going to multiply by 5 over 4. Over here, multiply by 5 over 4. 5 over 4 times 4 over 5, that'd be 20 over 20, which reduces to 1, so it's just x, equals. And now I'm going to want to try to cross-reduce over here too. So the 8 and the 4, they're both divisible by 4, so that becomes a 1 and a 2. But you have to remember that the negative sign is actually still there. We don't cross-reduce the negative, just like we learned about in our number systems unit. So that's negative 2 times 5, which is negative 10. And again, I would like to check my work. So 4/5 times negative 10, which is negative 10 over 1, equals, and then, I can't even read that number, I'm sorry, equals negative 8. And then we can cross-reduce. So 2 and a 1, negative 8 does equal negative 8. So I can check my work. Okay, example number 3. With example number 3, I'm going to actually rewrite it. We don't want to have just like a negative number kind of hanging out in the middle of nowhere. We learned in the first unit that usually you're going to take that negative sign and put it in the numerator, so we can go ahead and do that. But truthfully, it doesn't matter where the negative sign goes as long as it's either on top or bottom. It can't be on both. So I'm going to multiply by the reciprocal, which is 2 over negative 1, or negative 2 over 1, it doesn't matter. And then over here, same thing, times 2 over negative 1. And I can't cross-reduce anything because there's no common terms. I don't like terms. So, but over here, 2 over negative 1 times negative 1 over 2 would be negative 2 over negative 2, which is just positive 1, so x equals. And then this would be negative 18 over negative 1, which reduces to just 18 because a negative divided by a negative is a positive. Okay, number 4. Same thing. I need to move the negative sign. It can go on the top or it can go on the bottom. It doesn't really matter. And I'm going to multiply by the reciprocal again. So times 5 over 6. But I have to remember that this is a negative number. So this needs to also be a negative number. Otherwise, it's not going to fully cancel out. So I'm going to multiply this side by 5, negative 5 over 6. Okay. Negative times negative is a positive, and all the 5's cancel and all the 6's cancel, so I'm left with just x equals. And then here, that becomes a 1, that becomes a 2. 2 times negative 5 is negative 10. All right, and I want you to try the last two problems, number 5 and number 6, by yourself, and we will go over it tomorrow. But the one thing I want to remind you is that this number right here is going to need to become improper in order to operate with. Thanks for watching. Have a good night.